Hi, so today we're going to learn about insertion sort and merge sort. We're going to look at a visual explanation of how these algorithms work, and then we're going to look at a code and try to understand the implementation of these algorithms. Starting with insertion sort. So let's go ahead and look at this array of 5 elements. We have 23, 1, 10, 5, and 2. Essentially, with insertion sort, what we're doing is we're dividing the array into a sub-array, and then we have a key, and we're trying to sort that one element into that sub-array. So essentially, we'll understand as we go through. So in the first pass, our sub-array is just this one element. In the one element, our key is 23, and because there's only one element, we assume that it is sorted. Therefore, in this sub-array, 23 is sorted. Now, in the second pass, our array grows, and our sub-array takes into account the second element, which is 1 and 23. Our key is 1, so we're trying to find the correct place for 1 in this sub-array. And then we check if 1 is in its correct place. We check if 1 is in its correct place. It is not. It compares it to the element behind it. And because 1 is smaller than 23, we swap those places. Now, let's understand it on a bigger sub-array. Now our sub-array becomes 1, 23, and 10. This is our sub-array. Our key is 10. In this 10, we're trying to find the correct place for 10. We compare it with 23. It's shorter, so for now, this is the correct place. We also compare 10 with 1, and because 10 is greater, the correct place for 10 is between 1 and 23, so we place 10 over there. Now, let's look at the fourth pass. In this, our sub-element has grown to the 4th index. Our key is 5, and we're trying to find the correct place for 5. We compare 5 with 23. 5 is smaller, so we compare 5 with 10. 5 is again smaller. We compare 5 with 1, and because 5 is greater, it's placed after 1. And then our sorted subarray becomes 1, 5, 10, 23, and then our subarray then grows to encompass the entire array. And the key for our subarray or the entire array becomes 2. We compare 2 to 23, it's smaller. We compare 2 to 10, it's smaller. We compare 2 to 5, it's smaller. We compare 2 to 1, and because it's greater, it gets placed after 1. Now, the entire array has ended, and because we have found the correct position for each of the elements, we assume or we know that the entire array is sorted. Let's go ahead and look at how to implement this algorithm. To look at how the algorithm is being implemented, let's start at our main function. In our main function, we have defined an array 12, 11, 13, 5, 6. Now this is in reverse order. Therefore, the algorithm that we implement will have the worst time complexity. We are also calculating the size of the array because these are the two parameters that are being passed into the algorithm insertion sort. Now let's go ahead and look at how insertion sort has been implemented. We have an array that is being passed in and n, which is the length of the array. We define 3 variables over here, I, j, and key. I is there to keep track of the element in the entire array. J keeps track of the element in the subarray starting from the right-hand side and ending towards 0. And then key is the element that we're trying to put in the correct place. Inside the first for loop, we go inside and set our key to the element that is going to be sorted. So essentially, every time we increment I, we're in the bigger in the entire array, and we're trying to find the position for the element that needs to be put in the correct place. We set j to just before I because that becomes our sub-array, and then we have a while loop trying to find the correct place to place our key. Now inside the while loop, we have two conditions. J is greater than or equal to 0. This makes sure that we're never out of bounds of our array. And then ARR of j, which is array of j, is greater than the key. Now this will make sure that we are putting our key in the correct place. If it is smaller, we are going to find the place that we need to put it in. And we do this operation, ARR of j plus 1 is equal to ARR of j, which is if the key is not smaller, then we move the array one place up because we do not want to lose the element that we are going to be replacing. So essentially, if we look at our diagram over here and we look at replacing 1 and 23, if 23 needs to be replaced and needs to go here, we need to make sure that before we put in 1 into this place, we are putting 23 over here, and the element that needs to be placed in this place is being held by the temporary variable key. Going back to our code, this while loop ends when it finds the correct place for j, and then we put it in the correct place. Now we do j plus 1, and this is going to be easier to explain if we're trying to replace the first element. Now essentially, if we're trying to replace 1, our j is going to stop when it's at 0. When it's at -1. Because essentially the loop will stop at 0. The loop will go to 0 because we have our condition equal to 0, and our j will become -1. So essentially it's at one place behind, therefore we add one place and we put our key, therefore the element that needs to be sorted, over there. And that's how the insertion sort works. Now let's go ahead and we're going to look at how merge sort works. Okay, starting with merge sort, we have an array of 8 elements over here. How merge sort works is on the basic principle of divide and conquer. This is a very common algorithm in computer science, and we're going to look at firsthand how merge sort uses this algorithm or this concept to essentially sort our array. Now, essentially what merge sort does is it keeps breaking the bigger array into smaller arrays, dividing them into half each time, and then sorting these arrays elements by elements. Now, essentially this was 8. It gets split into 4s, then it gets split into 2s, and then it gets split into 1s. And now at this point, we compare whichever element is smaller gets put into the first place, and then whichever's bigger gets put into the second place. And this happens for each and every sub-array. Now essentially, when we're at 2s, what we do is we declare a counter variable over here I, and we declare a counter variable over here j. And what we do is we compare I and j, and whichever one's smaller, we put it over there, put it in the first place, and then we increment whichever sub-array we took it from, we increase that. So essentially, because we took from this sub-array, we're going to increment I to become 2 or 1 if you're counting from 0, and then it's going to compare this place and this place. And now because 4 gets put in, it's going to put 4 over here, increment j variable, and put it over here. And now I and j are compared again, and the smaller one gets put in, and there's going to be a condition which is out of bounds, and then the last one gets put in. And similarly, it does it for this for the other subarrays as well. And then when we're at the bigger one, again, we're going to have an I variable, we're going to have a J variable, and it's going to compare, and then it's going to have our bigger array, which is going to be sorted. Now, essentially, during the algorithms, all of these steps may not be done in the same order as I spoke. However, this is the general gist of the algorithm, and that's how it works. In addition to I and J counter variables, we're also going to have a K variable, which is going to look at the subarray in general. And I will explain that more when we look into our algorithm. Now let's go ahead and look into our algorithm. All right, so let's go ahead and look into our merge sort algorithm. Now, essentially, this algorithm utilizes the 3 different functions. This could also be done in 2, but as programmers, we're trying to make sure that if we write a function, we are making sure that function is easy to call and is always using the same parameters. So for insertion sort, what we did was we were passing the length and we were passing the array. So following the same parameters or the same signature, we're going to do the same. However, this can also be done in a single step. But because we're good programmers, we're going to make sure that we're following our same signature. What merge sort does is it calls merge sort recursion, which is another function. Now, essentially, because merge sort is utilizing divide and conquer, it also utilizes this key concept called recursion. Now, what we sort the arrays using recursion. Now, essentially, there's going to be 2 different functions. The merge sort recursion is going to keep splitting the arrays, and then merge sorted arrays is going to merge the sorted arrays together. Now, the merge sorted arrays is named that way because we're considering each element in the subarray if in the subarray is always going to be sorted. So essentially, let's go ahead and look at our recursion function, which has an int a, an L, and an R. So essentially, this first function, merge sort, which we're calling, we're passing the array itself, we're passing the starting of the array, which is 0, and we're passing the ending of the array, which is length minus 1, which merge sort recursion receives. And the merge sort recursion is going to call itself multiple times till it reaches the single element. Now, essentially, let's go ahead and look how it works. We're passing the array itself. We're passing L, which is going to be the left part of the subarray, and then R, which is going to be the right part of the subarray. The recursion keeps happening till the left part is smaller than the right part. Now, essentially, what this is going to do is make sure that the elements always become or get dropped into single elements and the subarrays become one single element. We calculate M, which is the middle point of the array, by doing L plus R minus L divided by 2. Now, essentially, let's look at this. L in our first pass is going to be 0. R minus L is going to be, and this is because it takes into account recursion. So in first pass, it's going to be R minus 0. But in the second pass, it's going to be, because L is going to get split into 2, the L might be different because the left part of the subarray might be the right part to some other subarray. Now, essentially, we're calculating the middle point so that we can split the arrays evenly. And then we call the merge over the left part, merge sort recursion, so that we can split them further over the left part and then over the right part. So left, middle point, and right. and we do m plus 1 because we don't want to split the middle element twice. So we do left to middle point and then one element after the middle point to the right. And then we call this function called merge sorted arrays. And this is going to sort our subarrays together and then merge them. Now let's go ahead and look into how it happens. Essentially, when we come over here, we're making two variables, left length and right length. Left length keeps into account the length of the left subarray, and then right length takes into account the length of the right subarray. We create two temporary arrays, the left subarray and the temp right subarray. And we then copy the data from our big or our main array into these temporary arrays. And this happens using a for loop. It's a simple for loop. It starts at 0, goes till I is lesser than left length, and then increments I by 1. And I starts at 0 because we're putting our elements into temporary arrays. And similarly for the right subarray, and we're putting them into the right part. Now you're seeing we're doing L minus I, and this is essentially because L might move over different subarrays, and then plus I, essentially I is going to be 1, 2, 3, till it reaches the left length. And similarly for the right subarray, we start at m plus 1 and we go till the end of the right subarray. Now, essentially, let's go ahead and look into the merging step, and this is going to be the major step of understanding how merge sort works. We create three different variables, and these are all counter variables, int I, int j, and int k. Int k keeps track of our entire array. It does not keep this is not keeping track of the subarrays. It keeps track of our entire main array. Int I keeps track of the left subarray, and int j keeps track of the right subarray. Now inside the while loop, what we check, the first thing that we check is I is lesser than left length and j is lesser than right length. This is the step where we're checking if we're within the bounds of our arrays. And then we go ahead and we have an if-else block. The if-else block essentially checks which element is going to be put where. So essentially in the first part we check temp left of I is lesser than or equal to temp right of j. Essentially we're comparing our left and right, and this part of the if-else blocks checks if the element should be taken from the left subarray, and the else block places it from the right subarray. So essentially, if the if block is true, it takes the element from the left subarray and places it into the main array and then increments I. However, if this statement is not true, it takes the element from the right subarray, places it into our main array, and then increments j. And then essentially when this is done, we also increment k before we go into our next iteration. Now essentially when this happens, and if the array is odd, we're going to have one element left from either, or many elements left from either the temporary left or the temporary right. And what we do is we check, and because only one of these elements will be filled, however, we still need to check both the subarrays. We check while the subarray is not completed, and then we keep placing them one after the other. And we can do this because we assume that the subarrays are going to be sorted after this step. And that's essentially how merge sort works. And hopefully this video was helpful for you. And All the best!